Today we're going to be doing this here within Three.js. Look at that. What's up everybody, Gary Simon here. So today we are stepping back into the world of Three.js to learn more basics and fundamentals. And of course you can't talk about Three.js without talking about particles. They're very fun, they add texture and they add a lot of different things and aesthetics to your design. So we'll be checking out that. Just to show you real quickly the project again, if I refresh, we have an animation. This is help, and this is created by GSAP, these very simple animations. We have, you can see, custom little particles. They're actually little crosses you can see in the background. I'll show you how to do that. We have this geometry here that has their own particles as well, which gives it a very interesting aesthetic. And yeah, that is basically it. Make sure to check out the Three.js playlist that I've created here. There's about 4 other videos so far I've created within the last month or so. And especially if you don't check out all of them, make sure to check out the first one, because I will be describing the boilerplate code, because we will be starting the project off not from scratch. We'll be using a GitHub repo that I created for this purpose. So anyhow, I'll stop talking. If you like this, make sure to subscribe and let's get started. Now wait 1 second, you're about to watch me work with some intermediate to advanced front-end development stuff. Now, if you're not very good at front-end development, like in terms of HTML, CSS, and JavaScript, make sure to check out the front-end developer career path at scrimba.com. They've recently launched their front-end development career path, which is a collection of courses that cover HTML, CSS, JavaScript, React, and much, much more, as you see. It's over 75 hours of awesome content. There are hundreds of interactive coding challenges, and it's all geared towards helping you go from beginner to someone that's hireable as a front-end developer. So check out the first link in the description below to get 50% off. All right, so basically here is the Three.js Webpack Starter, and I've already explained this in the first video that's a part of this playlist. And we're gonna use this just to get up and running with a quick boilerplate. So we're gonna go to code and copy this address. And I'm going to go to my Visual Studio Code. I have just like a new window open, but no folder. We're going to go to Terminal, and actually no, we're going to go to View and Terminal. And then down here, we're going to hop into our code folder, wherever you store your projects at. And I'm going to git clone, so you're going to need the Git client. Google that in terms of how to install that, depending on which OS you're using. And right click to paste that, and then we'll give this a name of like particles. Something like that. All right, cool. Now let's cd into particles, and then we'll run npm I to install all the dependencies that are a part of the project that we just downloaded, and it should go pretty quick. And then we'll go ahead and npm run dev, in which case it will launch a quick development server and your browser, depending on what is default. And here we go, we have this spinning red torus in the middle. All right, so let's go ahead and now open up that folder. So we're gonna go over here, I'm gonna go to code, we're gonna go to particles, which we just installed, select folder, and there we go, we are inside of it. So we're gonna go into source, and then we're gonna go to, let's see here, script.js. All right, so this is where we're gonna be working for the most part. Now, this whole file right here, I go into more detail in the first video that's a part of this Three.js playlist. So make sure you look at that. It would also probably make sense a little bit to check out some of the other videos before watching this one. Although this one's really simple itself, so at least just watch the first one. Okay, so right now we have a single object, and that object, of course, is that spinning red torus right here. So this object, it has its own material already. It's defined right here under material. Here's the object geometry. Now, remember, when it comes to having objects in Three.js, you have to have, it's like a 3-step process. The first thing is you have to have the skeleton, which is the geometry. You have to have the meat, which is the material, and then you have to have the mesh, which kind of combines both of those right here, and then you add it to the scene. So really, it's kind of like a 4-step process. And what we want to do is change the material here, and we want to make it look like it has particles on it. And this is a very quick and easy way of getting up and running with particles, essentially. or they look like particles on your geometry that's already defined. So what we'll do is we're going to delete this. We're going to change this to a points material. We're going to open up the options here in an object, and for now we're just going to leave these empty. But we can't use 3.mesh to create a sphere that has a points material. We have to change this to 3.points. So it was mesh, but now it's points. All right. If we save it, let's check out what's happened. Okay, nasty. I don't know what I'm looking at. So the one thing we'll want to do is put in transparent true and save that. Obviously that doesn't do shit. So we're going to put in size 0.005 or so. And of course, these are values that you can experiment with. And there we go. All right. Oh, let's get that back. So as you can see, very cool looking. It presents you immediately with a very interesting aesthetic, albeit an aesthetic that you definitely don't want to overuse and use in every project. It has to make sense, of course. But we're not going to get into that too much. I just want to get into the technical know-how of how to create stuff like this. So obviously, when it comes to the size, you can easily start experimenting with the size of these points. That's 0.1. So obviously, you want to go, quite a bit lower, and depending, of course, on the aesthetic that you want. And so you could do this with any object that you have already defined within Three.js, just to create a real quick particle aesthetic. Now, what if you wanted to create your own custom geometry within Three.js? How do you do it then? Then it becomes a little bit more of an involved process. So for instance, we all have seen, there's so many different types of particle-based backgrounds and not just backgrounds, but other custom particle effects. We're going to create one kind of like just your typical star field of sorts, and then we'll make it move and interact based on mouse position and all of that fun stuff. So to do that, we're going to create another piece of geometry. All right, so we're going to have one over here. We're going to call this const, and we're just going to call this particles geometry equals new 3 and buffer geometry. All right, so you also have to determine how many particles that we want, and we're going to define that in a const, and we're going to call that particles count equals, and then we'll just go with, like, I don't know, 5,000. All right, so now after we have that, we have to create a float32 array. All right, and so we're going to call this position array, and the purpose of this property right here is to provide us with an XYZ coordinates for every single particle. And of course, if it's 5,000, we're going to have 5,000 times 3, because when it comes to Three.js and geometry, each of your particles or your vertices, or whatever you want to call them, have to have an XYZ attached to them. So the float32 array basically does that, and I'll show you what I mean more specifically. So we're going to put equals new, and this is going to be float32 array. We take our particles count and multiply that by 3. And so what ends up happening is it's kind of like XYZ, 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 XYZ. And that's how this float32 array for position array is kind of structured. All right, so then we're going to iterate over these with a for loop. So let I equals 0, and I is going to be less than particles count times 3, and then I plus plus will increment it each time. All right, so as we go through this, then we're going to specify the position array. We pass in the I value, and so this is basically XYZ, and then XYZ, then XYZ. And we're going to put in, just for now, math.random. All right, because we want these, when it comes to a star field, they're just kind of randomly positioned, each star, or in our case, a particle. So we can't just save this yet. We haven't added it to the scene. So what we want to do now, the final step in this before we get to add it to the scene, is we're going to take our particles geometry, and we're going to set the attribute of each one of the particles, and it's going to be the position attribute, and new 3 buffer attribute, the position array, which we've defined above in the for loop, and then we pass in 3. All right, I know it's a little bit convoluted looking, but basically what this is doing is it's taking this position array that it's created, and it's gone through and added these math random values for each one, and it's setting the attribute of the position attribute rather of our particles geometry from this 3 buffer geometry up here, and just assigning all those random values XYZ XYZ to all 5,000 of the particles. All right, so now what we can do is go ahead and we can come down here and we can create our const, we'll just call this particles mesh, I guess, equals new 3 dot points. Same exact thing, we're gonna pass in our particles geometry, and we'll pass in our material for now, all right? After that, we're gonna specify particles mesh as well. All right, so this isn't gonna give us the desired effect, and of course it's errored. Particles is not defined. Where am I at? Let's see here. Particles count. There we go. Now let's refresh. And here we go. So not exactly what we wanted, obviously. So the first thing we want to do is get this position here in the center, all right, because it's up here on the right. And to do that, oh, by the way, something really funny. I already just recorded this whole tutorial. It was like 45 minutes long, and then I realized I clicked this little button on my mouse, which switches my camera from my desktop to me. And so half the video was me. So I have to re-record everything that I already did. It sucks. Okay, anyways, that's the life of a YouTuber. Let's go ahead, Shift Alt down to replicate that, and we will comment that out with Control/. And to get that to the center, we're gonna put minus 0.5. All right, so now if we save, we'll see now it is in the center of the screen. Now what we need to do is we just need to disperse the particles more so in every direction so that it consumes the screen. So all we have to do is multiply it by a certain factor. So we'll go ahead and comment that out. We're gonna put these in parentheses to perform the action first, then multiply the result by 5 or so. And of course you could play with that number just to see what happens. And there we go. Very, very, very simple. You can also do other things. Don't be afraid of playing around with the math, even if you don't understand it. For instance, I was trying to see what else I could do, and so what I did is I decided to wrap this in parentheses, another .math.random, and multiply that by 5. And what happens then? Well, actually, it's kind of hard to tell, but you can see there's a lot of particles that are kind of situated more so on X and Y in the middle, and you can really see this if you bump this number up from like 5,000 to 50,000 particles. So it creates just very interesting, cool effects that you might stumble upon by accident. I'm gonna leave it like this though. All right, so now what I want to do is I want to create 2 different materials so that we could control this torus material independent of the background. So let's do that real quick. So what we'll do is we'll take this, we're gonna call this one, we'll just call this particles material. Yeah, particles material. And it's gonna be another points material. So we're just gonna put that right here in particles mesh. So now nothing's gonna change, of course, because they're exactly the same. But let's give this one the star field, essentially, some different properties so that we can experiment with it. So let's say, for instance, we don't want these default squares. We want to use a custom texture or sorts. So I already created in the static folder cross.png. Now, if you downloaded the starter, this is not going to be in there. I'm going to try to remember to create another GitHub just for this project, and you can clone that, and then you'll have access to this little cross.png graphic. It's only like, I think it's like a 10 by 10. It's just like, it's alpha, so the background's transparent, but there's a white cross in the middle. That's all it is. So you can create this easily on your own if you wish, like in Photoshop or whatever. So if we go back here, what we want to do is we want to use a texture loader to get that in there. So we're going to say const loader, loader equals new 3.texture loader. And then we're going to say const, we'll call it cross equals loader.load. And then we don't reference the static folder that's inherent already. So we just put like /cross.png. Now we come back down here and then we simply use the map property. Cross. Now what's going to happen? Nothing. Why? Because there's transparency that's baked into the PNG, but we have to tell our material that it is transparent true. All right. So now when we do this, we see these little crosses, which is pretty cool. It's not that cool yet. What if we want to change the actual color? Well, you can do that. So we can do color, blue, for instance. Oh, that's not good. What did I do? Oh, there's a comma that I forgot to add. There we go. So you can see you could change these to all different colors. You can animate the colors if you wish. And the colors also can work without these two properties here. So if we save this, it'll change, the default squares as well. So let's leave that there. And also there is blending. So if you're familiar like with Photoshop or many of the graphic design software like Figma or XD, like blend modes, there's blend modes as well. We won't be able to tell it in our particular example, but this is how you would do it. It's the blending property with like additive blending. Like I said, you won't be able to tell it in our example, but you do have that option. I think you can really tell, like if you have a ton of particles that have transparency baked in. But yeah, nonetheless, actually, let's just try it now. I'm not sure because I didn't experiment with this beforehand. But if we take our particles count and go to like 50,000, I'm not sure if we'll be able to see a huge difference. No. But either way, you do have different types of blending that you can use. So let's go ahead and just get rid of that. And also, I don't want that either. We're just going to leave this normal, leave this back to 5,000, and this is our result. Okay, let's change the background color. And so in previous videos that are part of this Three.js playlist here on YouTube, I was just making the renderer transparent, and then I was changing the background in HTML on the body selector. But we could just change the background here as well within the renderer. So right down here, we're going to specify our renderer set clear color. So renderer set clear color, and then we put in a new 3.color, and we specify the following color code: 21282A, and then 1 for opacity. So there we go. It's kind of like a dark desaturated blue. Obviously not quite as dark as the black that we had before, but this works here. I like it a lot. All right, so now let's make this move, like the star field background. So down here is the tick function, and request animation frame, which is just inherent with JavaScript, has nothing to do with Three.js. We'll call this on every frame. So like 60 seconds, this is being called every single time. That's how we're getting the sphere to rotate. We want our star field sort of thing to rotate. And I think we called it particles mesh. So what we can do is particles mesh dot rotation dot y, just like the above, and we can say mouse y times elapsed time times. Well, let's just do this. Now, mouse y doesn't exist yet, so we have to get access to the mouse movement essentially. So let's just put mouse up here, and we're going to create an add event listener on the document, and we're going to do mouse move, and we're going to call a function called animate particles. All right, so first let's create some properties here, and mouse y we want as well, and then we're going to say function animate particles. We're going to pass in the event mouse y equals event.clientY, and then mouse x will be the same thing. Awesome. So now every time we move we're going to get the X and Y axis of where the mouse position is. So then we have mouse Y right here. So let's save this. And now we can move this, and it's going crazy, and it won't stop moving. This is kind of a cool effect, but it's a little bit too much. What we want to do is we want to multiply this elapsed time. This elapsed time just gives you like how much time has passed. So what we can do is multiply this by like 0.00008. Not 4, 8. There we go. Save. All right, kind of interesting. Let's change this to a mouse X. Wait, no. Change this to X and leave that at Y. All right. Uh-oh. Why is that not working? No error. Let me make sure I got this working. Oh. This was capitalized. I think my caps lock was on. There we go. I'm wondering what is going on. All right, so what if we wanted to reverse this? So when the mouse goes down, these go in the opposite direction. We could put a negative right here. There we go. All right, now let's do the same thing with the Y. So we'll take the Y and we'll put mouse X here. And of course, you could play with these, like X could be X or Y could be Y, and putting negatives here and there and whatever you want. So it's entirely up to you. And there we go. We kind of have this interesting sort of aesthetic here. Now, why is it when we refresh and we don't mouse over, it's completely not moving at all? Well, we want to fix that. And the way we can fix that is because, or what we can do rather, is we can say if mouse X is greater than 0, then only change these right here. So now, if I refresh, I must have screwed up somewhere. Mouse X is greater than 0. Oh, yeah, that's why. Silly me. So what I want to do is take our particles mesh rotation.y equals, we can just do negative 0.1 times elapsed time. All right. So now it's going to move, and now there we go. So refresh, we have movement, and then it changes. And of course, you could do with other different things, like if you move it, like it'll gradually slow down based on the direction. I'll leave that up to you all to experiment with. So now let's switch roles and get into more like UI design stuff with HTML and CSS, and maybe have like some sort of like headline on here, and we'll animate it with the Greensock Animation Platform or GSAP. So to do that, let's go over to index.html. And in our index.html, it's going to be very simple. We're just going to have a class of container. And inside of here, we'll have a class of content. Inside of there, we'll have an h1. The next, we'll do a break and then dimension. We'll have a paragraph. I'm going to copy and paste this just because I don't want to type this all out. All right, the journey in the next dimension with this crazy particle effect. Okay, and that's it. That's all our HTML will be. Of course, we're not going to be able to see it because we have WebGL in our CSS is position fixed and it's sitting on top of everything. So what we'll do now is we're going to make our color white because right now everything's black, so all of our text will be white. And we're going to specify just a few selectors here. So for container, we'll do position absolute and z-index of 1. So if we save this, now we can see our text. All right. Additionally, we're going to take our width 100%, height 100 viewport height. Of course, if you do 100 viewport height on any elements that you want to go all the way to the bottom of the browser, you have to put height 100 viewport height on the body element at least. And then we'll also specify display grid and place content center. That places everything vertically and horizontally in the center. All right. Next up, we'll have our content class, and our content will be display flex, a gap of 5 em units. So now we have this. We'll do a width of 100%, a padding top of 3 em units, and then a position of relative. Now, of course, this isn't going to change much except just move things down. But the reason I did padding is because we're going to have a pseudo element of before to make a border top go all the way across. So here's how that looks. So we'll put content before and content empty and position absolute. So this is another one of those patterns where these two properties work in conjunction with position relative, so that when we do top 0 and left 0, it's in it's in relation to its parent container of content rather than just going to the very top of the browser of top and 0. So hopefully that makes sense. Something I use all the time. Width will be 100%, and then a border bottom will be 1 pixel solid white. And then we're going to do transform scale x 0. Now, you're probably wondering why are we, or 1 rather, why are we setting it to its default setting anyways? Because CLX would be 1 no matter what. Well, it's because we're going to use GSAP to animate the transform property, and so it has to be set already here on this pseudo element. So now let's save this, and we see this. All right, things are looking a little bit small, so let's adjust some things here first. H1 font size is 4 rem units. Width will be 50 viewport width. Line height will be 97%, not 987. I'm trying to type too fast because I already did this like 3 times. And then we'll do text align right. Let's see what that looks like. All right. And then we're going to take our H1 and our paragraph, which are flex items. And there's going to be flex basis 0, flex grow 1. And these are 2 properties you use often just to create a 50%, 50% 2 column layout. Okay. And then we'll also put in clip path, polygon, and we're going to put 0, 0, 100% 0, 100% 0, and 0, 0. Now you're wondering what that does. Well, it hides everything. If we go to CSS Clippy, which is a tool I use all the time for clip path makers, and we use trapezoid, and then we just push everything, I believe it's up, and that's how we get this value, and that's why everything's hidden, because it's only, when you use the clip path property, only what is visible will show up. All right, and then we'll animate this down into this property with GSAP in a second. All right, so finally, let's change the paragraph real quick. The font size will be 1.3 rem units, and then a width of 40 viewport width. And this is what we have. All right, awesome. So now let's go back to our index.html, and we have to get our GSAP CDN and also the CSS Role CDN. So GSAP 3 CDN, we need to get this. So we copy that script tag. And then also we need the CSS Rule plugin right here. And I'll tell you why in a second. So we're going to do script. We'll just write this here inline. And basically, in order for GSAP to gain access to this transform scale element, because we're going to take that border and just kind of scale it out from the middle, because it's in a pseudo selector or pseudo element, we need to use that plugin that gains access to that. So what we do is we're going to say COTS content. Really, this should be called something more suitable, like border or something, because that's what we're trying to animate here. CSS Rule plugin, get role, content before. All right, and then we'll do a couple more. We need our H1 element because we want to animate that clip path property. Shift Alt down. We'll do a paragraph here, because we want that, we want to animate that, and then we're going to create a timeline. So TL equals GSAP.timeline. So then we say timeline from, you can also use 2, we will use 2 in a second. So we're going to go from these properties that we specify to whatever is default in the style.css. So we're going to take our content, which is going to be the border that we want to animate at the top. And inside of here, we're going to put CSS Rule, and then scale X 0. Let's save, go back, and if we refresh, we'll see it kind of goes real fast. So let's change, add a couple other things. We're going to delay, so 0.5 seconds for a delay before this begins, just to give us a little time so it's not immediate, and then a duration of 4 seconds. So we'll save this, and there we go. We'll play one more time. All right, cool. So then what we'll do is TL2, we're going to put in our H1. We'll do a duration of 2 seconds and then a clip path. Now remember, when it comes to CSS or CSS in JavaScript, whenever you have properties that are like clip path in CSS, you get rid of this, the hyphen, and you capitalize the next character. So it's camel case. So clip path. And then we do the polygon where, it is extended all the way. Do I have that up still? No, I don't. Okay, well, you know what I mean. I'm going to copy and paste that here off screen. So this is the actual code that we want to use. Let's save this. Now here, it's going to happen only after this is done. We're going to fix that in a second, but now it comes down. All right, so if we want it to happen sooner, we put in the third parameter, we want to subtract 3 seconds. Of course, you can plus and add, as well if you want. And there it goes, it happens faster. Now we're going to take this, change this to a paragraph. This is going to be a duration of 4 seconds. The clip path is the same, and this will just be an offset of only 2 seconds compared to 3. So now we'll see them both come in. And then finally, one last thing that we'll do is we're going to take both of them and make them fall down. So we'll put Y and 30 pixels or so. So copy this, paste that, and they're going to subtly fall down. Kind of like that. And that is it. Very, very, very cool stuff. Hopefully you learned quite a bit here. All right, so hopefully you enjoyed that and you learned something new. Make sure to check out the whole Three.js playlist if you haven't, and there's a lot of other cool stuff that I've been showing, and there will be much more cool stuff in the future as well. So make sure to subscribe, and I'll see you real soon. Goodbye.